Hello and welcome to Mission Control Houston. We're going to have a special conversation with one of the flight controllers that works here in the International Space Station Flight Control Room. This is Amy Brezinski. Thank you for joining us, Amy. Amy works with the Onboard Data and Interfaces Network, so she's called an ODIN flight controller. So Amy, can you tell us a little bit about what you do as a flight controller?
Sure. As a flight controller, it's my job to monitor and command the space station, specifically for the CDH system, for the command and data handling system as an ODIN. I'm responsible for monitoring over 48 computers on the space station that control the space station and all its systems. Part of my job, I'm also responsible for uplinking software to support the activities that we do on the space station. And also I'm responsible for moving data around the space station and bringing it also certain pieces of data down to the ground through special data dumps.
Okay, and the computer set up on board the space station is sort of, everybody thinks of your desktop computer that you have, but also the space station is run by computers. So those are a lot of the computers that you're monitoring, right?
Right, so it's a little bit different from what you think of at home as your computer. They're actually like boxes, and there's over, like I said, over 45 of them. And then the crew interfaces with them through laptops. So when you look at a computer, sometimes we call them MDMs. It's a multiplexer, demultiplexer. It's our fancy way of saying computer. It just looks like a box, but there's a lot going on in there, and that's what we use to keep station running and keep all the systems running and get all the data to the ground, so that other flight controllers can monitor their systems.
Okay, and what sort of background do you have that helps you get ready to be able to do this work in mission control?
Well, for one, I'm an aeronautical and astronautical engineer, and so I had a basic engineering education whereby I learned all the principles of engineering and a little bit about computers. And then when I got here is really when a lot of my training really began. I went through 2.5 years of training to become an ODIN, and I learned all about the computer systems that we have on board, the networks. We use 1553B networks, which is kind of an older but very robust network used in a lot of space and aircraft systems. And then I also learned how to be a flight controller and how to communicate effectively with the rest of the team, be able to listen to multiple conversations, be able to solve problems as they come up based on my knowledge of the system. So I think my background education definitely helped me in engineering, and then when I came here, I really learned a lot about computers and the system on board.
Is your position in mission control the similar setup as many of them, where they have a back room where you learn how to do specific areas and then come to work in the front room, we call it?
That's right. So when I started out as what we call a Raven, and that's the back room for ODIN. And it's the Resource Avionics Networks Engineer. We use a couple letters there to make Raven. And I started out there, and that's the back room is really the systems expert. So I learned to become an expert in the system and understand how all the different software and the different computers work, because it's all different, and understand how to do the job. And then eventually I moved into the front room and kind of learned more about the other systems and how the computer system interfaces with them, so then I could better address failures with the team.
And you were the lead of ODIN for Expedition 30, so what does that entail?
It's a lot of fun to be the lead for an expedition. We had a really great crew, and this was a very exciting time for our system because we actually upgraded a lot of the computers, both from a hardware standpoint and from a software standpoint. We upgraded 7 of the computers with the new processor cards that have flash memory on them. So that's a pretty big upgrade. We have a lot more processing power now. And then on top of that, we actually changed the software on a little under almost half of the computers on board. So it was a very dynamic time, and it was me and, of course, a lot of people that I work with in my group as a team were able to execute these activities. And the crew was essential. I mean, they are our hands and our eyes up there. So they actually performed the card changes. They had to take out the computers, open them up, take out the old card, put in the new card, put it back into the rack, and then we would activate the computer and check it out. So it was very dynamic, and we're very excited about the changes, and it was a very, very good increment.
And all of it went well, it sounds like?
All of it went very, very well, yes. Lots of planning and very good execution, very smooth.
And from what I understand, it's the most transitions that we've done in a certain time period?
That's right. So in total, we had on the U.S. computers 4 software transitions, and that's a record for the most ever done in an increment. We also transitioned beyond the computers a piece of equipment that does routing of fiber optic type data, fast, high data rate information. So we had transitions to that as well. And then our international partners also had some notable software transitions. The Russians did a transition with their computers and upgraded the software, and our ESA friends did as well. So lots of new software.
And that all is to help the space station stay up to speed and work better and support all of the research that we're focusing on now, right?
That's absolutely right. One of the big changes we made is we did that hardware change out for our payload computers, and that increases the ability to do more science and get more science data on station. So the science community and the research community was very excited about that.
And will you be watching the landing overnight?
I will. I'm actually planning on coming in here and watching it from our viewing room. I'm very excited. There's a couple of us from the increment that are coming in, and we're used to working in the middle of the night as flight controllers, so it'll be very, very exciting to see Dan, Anton, and Anatoly come home. We're looking forward to it.
Well, thank you, and congratulations on the successful increment, or expedition as we call it, and thanks for telling us more.
Thank you very much.